Hi, my name is Sarah Pritchett, and today I'm going to be talking to you guys about DNA analysis, more specifically DNA sequencing. DNA sequencing is the sequencing process of determining exactly how your adenine, thymine, cytosine, and guanine go in a line. There are many different methods of determining this. Today I'm going to be talking about chain termination method, also known as Sanger method. There's essentially 6 steps to it. First step is to denature your DNA, meaning to separate the 2 helixes into just one single strand. Apply your primer onto the template DNA strand, which is one of the strands you've gotten. Step 1. The third thing is to place your template DNA strand into the reaction mixtures. 4th, use gel electrophys. 5, take your X-ray. And then 6, analyze it for whatever you need. To denature your protein, basically the best option is heat because it doesn't alter how your DNA is structured, it just separates the helix. Next, you apply your primer. Primers are used in order to ensure your DNA is starting at the exact same spot every single time when looking at it. From there, you take those DNA strands and put them into reaction mixtures. Reaction mixtures contain 4 things. First, obviously, the DNA that needs to be sequenced. Secondly, DNA polymers, which allow the DNA to replicate itself many times. Thirdly, you have free nucleotides, known as dNTPs, which allow the DNA to finish off itself, just like finish off the DNA. And fourthly, there's modified nucleotides, which stop the DNA at various points in its strand, so that way you can see where it all lands. In gel electrophys. Gel electrophys is where you put your adenine, cytosine, guanine, and thymine into 4 different lines near the negative side of a gel pool. You send electricity going down the pool over to the positive side over here. The shorter the DNA strand, the further it will travel, versus the longer the DNA strand, the less distance it will travel. You do this in order, so this is where the modified nucleotides come in, is because they latch onto the DNA and make it so it can't continue on copying itself. So you end up with varying lengths of DNA strands. From there, you take an X-ray of that gel electrophase, and then it'll look something like this, and then you end up reading it all the way from the bottom because those are the shortest strands, so they got cut off the soonest, all the way up here to the larger strands. So you'd be like, alright, this block here is in the C column, and it's the one that traveled the furthest, so it's the shortest one. And you would just bounce back and forth going all the way up, and then you would analyze it for whatever you need, be it matching DNA and whatever things you need. Those are my sources I used for this. I will post them in the links bar below. Thank you for watching.